All right, I think we can go ahead and get started. Welcome, everybody. If you're here to learn more about our School of Engineering master's programs, you're in the right place. We've got a lot of great information to share with you, so we are going to go ahead and get started. We'll kick things off with some introductions. My name is Victoria Bray. I am the Associate Director of Recruitment, and I work with all of our School of Engineering master's programs. Ted, would you like to introduce yourself?
Sure. Good morning, everybody. Ted Tracy here. I'm the Master's Program Director for the Master's applicants like yourselves. And I also serve as an engineering faculty member teaching the School of Electrical and Computer Engineering.
Fantastic. So, like I said, we've got a lot of great information to share. We're going to talk about the program structure, curriculum. Going to talk about Brown more broadly and the unique resources that we have for master's students. And then we'll talk more about the application process. Of course, your questions drive the conversation, so feel free to ask them throughout the session. We'll be answering them in the background, but then, of course, we'll wait until the end in case things come up over the course of the session. So, I will hand things over to Ted to talk more about the program.
So we'll talk about the program, but I serve as the program advisor and I have a partner in Nora. She actually is the academic advisor. And what's unique about the structure for the School of Computer Engineering and Electrical Engineering is that we focus very much on your curriculum plan that you have over the next couple of years. So we work with each student very individually and just determine what are the right sequence of classes to take that will be most complementary to what you're trying to achieve. And like myself, there's another set of advisors throughout the organization for data science and for mechanical engineering and biomedical as well. So there'd be plenty of support from the faculty to help you guide your way in terms of the curriculum that you choose.
So then we also have a layer of support within the School of Engineering and Student Affairs. Anne's actually on the call. She's going to be answering questions in the Q&A, but we have these layers of support at Brown for our master's students, and they really start within the School of Engineering. So the School of Engineering Student Affairs staff are there to help you from now when you're interested in a program all the way through until when you graduate. They're there to help connect you with vital Brown resources, coordinate with other departments and offices to help you network outside of your program and within the School of Engineering. So really a ton of support in the way of student affairs and professional development within the School of Engineering, which we'll continue to talk about more throughout the presentation.
Great. And this is our new home. Actually, it looks a lot snowier today. We have a couple new inches of snow overnight. But we see our infinity sign, which is really representative of our program. We try to show that the program that you decide to go embark on has infinite possibilities. You know, whether it's you want to do research or study more closely in an academic area or have a mix of interdisciplinary skills that you develop, we pride ourselves on being very open and flexible and in a sense have infinite possibilities to pursue your graduate studies. Next, please. And the timing is really great. I mean, Brown is world renowned in terms of being diverse. We have ways that you can develop your own graduate program. We have a lot of flexibility about what you choose. Next couple bullets, please. And there's a wide variety of research and design efforts going on, both within the school as well as some of our neighboring schools. I think you'll find that the scale is very comfortable in terms of ratio from faculty to students. So you'll be on a first name basis with each of your instructors typically and be working closely with them on projects, for example. And then Brown itself, just from a geographic point of view, and Victoria will speak more about this, it's just a very convenient, collaborative type environments nestled between large cities of Boston and New York City as well. So you have access to those, but we have our own community, which is neat and allows you to really focus on your academic training and just learning more about the different college mates that you have with you. Next slide, please. And I've been around Brown for a long time. I went to Brown and had family members who went to Brown. I had my kids go to Brown, so I have a good perspective about the community and what we're doing. And I would say that to join Brown now is really very good timing. We have a great trend in the up and to the right direction in terms of investment, in terms of our leadership. We're investing in programs and research. We provide an awful lot of flexibility for you to kind of create your own program at that being said. So it's just a fantastic time to join because of the partnerships we have and the different departmental opportunities that we're going to talk through. And of course, the bottom line is, you know, Brown is in high demand in terms of admissions, both undergraduate and for graduate study. The thing that's always very timely, you're surrounding yourselves with really great students. And so that makes things a lot easier in terms of your own career development and academic development as well. Next slide, please. And there's a lot to choose from. And we have 430 graduate students roughly. We're trying to grow each of these departments on a regular basis. We have a very nice distribution of doctoral candidates as well as master's candidates. And then we have other types of degrees that are more programmatic, such as the prime school, which is for more of a business/technology orientation, for example. So all these programs are well represented and they're growing nicely. And from a diversity, inclusion, and just a concentration of different types of candidates from around the globe, we have a very nice mix as well. And we have a lot of meat on those bones as well. So we have 6 doctoral programs, which are more traditional type fields that we have, whether it's electrical and computer engineering, or chemical engineering or mechanical materials, those things you see on the left-hand side. So very deep in those traditional areas. And on the right, we're trying to innovate with new programs in terms of new master's types of concentration. So if you look at the bottom first, you can see that we've just introduced in the last 2 years a new sustainable energy program, which has a lot of popularity in terms of new applicants, and is very timely in light of the situation of global energy concerns that we have. And at the same time, we have programs like electrical and computer engineering, which I recommend and are growing on a regular basis. And there's great demand in the industry for that as well. And then we also have other types of majors that are concentrations like design, for example. And so for design, the MADE program is an example where you can learn the basic design engineering skills here at Brown, but we also augment that with classes and opportunities at RISD to really understand the field of design more effectively with some people that are really designers. Next slide, please. And to back up some of the words about the investment, we are hiring new staff members, new professors. This is always a very positive thing. This brings a new energy into the university. They each come with their own research areas and typically with some set of grad students and some prior research that they bring into Brown as well. So we feel very fortunate to have added 5 faculty members in the School of Engineering recently. And each of these are teaching grad classes and will be direct people that you would interface with in terms of some of the grad programs you may be interested in as well. And we'll talk about those classes as we go. When you get down to the program itself, you have one of 3 possible tracks that we like to call them, in terms of pursuing your master's, which typically is going to take 2 calendar years. You can get it done in a year and a half if you want. It depends how focused you are on getting out and getting back to whatever your activities were. But the 3 basic tracks are a scholarly track, which means that you're taking a deeper dive in terms of basic academic training in certain areas that you may have missed as an undergraduate, or through your working experience, you decided that you want to learn a little bit more about, or there's a field of great interest to you that you want to come really focus on and double down on. That would be the scholarly track. You wouldn't be doing research necessarily. You could still collaborate and take classes from across the campus in different departments, but really your mission at that point is to get through the program in a year and a half or 2 years, typically at the most, to take 8 classes and really go a little deeper and get that master's credential and have a much better intuitive feel for that area. The second program opportunity is research track, in which case you're not really certain whether you're going to go on for the full PhD or not, but you know that you enjoy research and you may be doing research with the goal of getting to a PhD program or getting back into industry and doing research as well. And so this is a program where you go a little deeper in terms of classes, but you go very deep in terms of actually doing research in a lab with a PI or principal investigator that you'd be working with. And typically that's a faculty member that you've taken a class from, that you've connected with well, and it represents an area that would be of keen interest to you as well. And then the third option is the professional track or the business track, if you will. And this goal is after you get your master's, you want to return to industry or possibly a different industry. And what you want to do is learn a little bit in the classroom, but augment that with an opportunity to work for a high-end, globally recognized company that will teach you a certain vertical market or opportunity. And who knows, that's an interview opportunity as well. So you may end up with that particular company after you graduate, and they have a chance to look at your skills more closely as well. So this is for a candidate that really is focused on trying to get into the job market, but with some additional skills and a much deeper academic training for a certain technical area. So those are our 3 tracks: scholarly, research, and professional. And they don't all have to be decided at the point of application. This is a good problem to have for us, that we get a candidate that wants to come to Brown, we work with them and talk about the 3 different options, and we build a program that will augment what their choice seems to be. And that may change a little bit over the course of a couple of years when you come to campus. Next slide. So let's talk about some of those classes. I mentioned that Pepe was one of our 5 new faculty members for the program, and she's very focused on cloud computing and cloud resources, which is extremely topical right now. And so what we're talking about is dynamic, on-demand use of CPUs and tensors and the ability to use things like resources such as FPGA design resources. So this is a very topical area that we're trying to integrate with and have some research and some understanding of how the internet is evolving and how computing resources are going to be available for us to do our research and our development as we go. So in very brand new topic, very highly sorted by many of the master's students as well. So great momentum for Pepe in our class and seems to be very topical for us. Next slide. One that I think is a really big hitter in the area of electrical and computer engineering is the design of systems on a chip or design of more sophisticated VLSI components. And Mehdi comes to us from the University of Michigan. He had worked there for years doing research on really high-end design and miniaturization of systems on a chip. And he's bringing that technology to our school and has a very good following of graduate students that are working to understand what VLSI is all about, but also actually to build a chip and build a system of chips as well. So this is a class where it's very participative. At the end of the first semester, you actually tape out and build your designs and hopefully have those working components working for you in the springtime as we go. So this is an opportunity to get some real hands-on experience with cutting edge tools and doing really significant designs that can be committed to silicon. Next slide, please. And we have very traditional areas of areas like mechanical engineering and materials and fluids engineering and fluid thermodynamics and all the things that you'd expect Brown to have. But this is a good example of a class when we got into the fluids, the whole area of fluids, we noticed that it represents great artistic value. And we turned this into a partial fluids engineering class, but also an ability to use photography in creative ways and imaging to show some really cool and interesting art. And we've actually built an exhibit in our ERC center to actually be a museum, if you will, for this whole phenomena of fluids engineering. So we can get the deep engineering and the mathematics behind the theory of it, but also we appreciate some of the artistic value of some of the areas that we research as well. Next slide, please. And an area that isn't so artistic but is really important and is cross department is optical microscopy. This is led by Kamani Toussaint, who's the dean of the organization as well. And his area is his PhD work and research is in optics. And so this is an area where we're bringing in optics and physics, engineering, mathematics, and we're pulling it all together to try to build better imaging, which can be used for many different purposes for medical research, biology research. It could be materials science and nanomaterials and things like this. So this scenario, Brown has put a lot of focus into microscopy and trying to do that with as many of the different resources that we have across the organization as possible. A lot of this is leading or affecting cutting edge research that could even be arguably Nobel Peace Prize research of ours as well. So a really important skill that we're developing in the school and Kamani is opening that up for students to join. Next, please. Now this is my class. I should know a little bit about it. And I took when I was at Brown, I took microwave engineering. And it was all about waveguides and the Smith chart and complex mathematical equations like Maxwell's equations, for example. But I've now taken the class over for the last couple of years. I have a couple more years to go, and I'm converting that into more about radio engineering and how do we use technologies such as the iPhone and Wi-Fi to actually communicate more effectively in today's world. So a little less about waveguides and a little more about antenna design and high speed, high efficiency, high frequency communication of all types of signals. And the world is growing so rapidly in this area, and we're just scratching the surface of our ability to explain that and get students to be interested in this area. So this is an area that's really growing for us nicely, and hopefully you'll see that in industry with some of your pursuits as well. And then another class we have, which is more of a capstone activity. I'm also involved with instructing this with a couple of founders that have created the class over 20 years ago, is we'll build an embedded system. And that embedded system has to have a microprocessor in it. We have to have firmware that allows you to develop the functionality of the embedded product that you have of interest. And then also you get the skills of developing how to build a system, both from a mechanical and electrical point of view. And so you can see the printed circuit board that we build. And there's no forced project that you have. You get to pursue the project of your choice, typically working in 2 or 3 person teams. And many of the teams, we had 33 students this last time around, and many of those are grad students. And they're all pursuing to build their projects in the spring time frame and actually have something they can show their friends and family and job interviewers and things like this. So it's a chance for you to actually get away from the theory a little bit and get into the practice of building an embedded system that's electrical and give you a chance to innovate and do something that could be a company startup for all we know. And it isn't all about technology and academics. A lot of people come to Brown in the master's program and want to do a little training in terms of organization development or business development. Many of our candidates will go work for small companies that represent complicated challenges as well. And so we have a good relationship with the Nelson School about entrepreneurship and organizational leadership. And Professor Banu here has a very popular class that explains how to work with large organizations, how to be a member of an organization, how to excel in those organizations, how to introduce new technologies and through those organizations, et cetera. So this is a very popular class for our tech people that are trying to get a master's, but maybe at the same time round out some of their skills or appreciate some of the business sides of their activities as well. And as I mentioned, we have new programs emerging, and one that's very popular, seem to have a very high uptick of applications. This recent cohort that we're just evaluating applications now as we speak. I'm sure you guys know that. But this sustainable engineering was a very popular new concentration that's just been on board for a couple years now. And it's all about trying to understand how we're going to solve and create new types of energy choices, and that's probably 75% of it. So you get in the real science of that and you can do some real design work, which is great, and look at competitive vendors that are in the space that we can learn from as well. But we're also trying to understand the policy associated with that. As we know, this is a global challenge that we all have. And the US could be very different than Europe in our approach. And so trying to have a broad view of how energy systems are going to be evolved over time and how we can address some of our global needs is very much the topic of conversation here. And so much so that you can get a full master's degree in that area. It's a very challenging, quick, I believe, 1 year program that will allow you to study all those topics from both the technology and the policy perspective as well. Next slide. So one of the questions that comes up, you can be thinking about whether you want to be a scholarly track or a research track or a professional track. But one of the tactics based on that is whether you want to do or have to do a thesis or not. You'd only really do a thesis if you were trying to go research path, but it's not even a requirement for you to do a thesis if that research may not be completely lined up with what you're doing in terms of working in your lab and your for your PI as well. So it's completely a choice. It's something like 15 to 20% of our students would choose to do a thesis. But the thesis is the end result of a commitment to actually do academic research. And so that's a question you can answer as you get into Brown in your first semester. You start shopping different classes, you meet different professors and potential PIs that could lead the research with you. And they invite you into their group. And if you're in that group doing research, then it may make sense for you to do a thesis. It could be a very good way to promote that activity in yourself or your next step in the career. It could be a way to get onto a PhD application, but it could also be extraneous to the path that you may be going, and you may not want to do that. So we make that decision as you get into the program. Probably at the end of your first semester is when you can make the decision about whether to do a thesis or not. And so thesis typically equals research and what kinds of things would I actually be spending my time at. And so again, we have very traditional fields like fluids and thermal sciences. Many PhDs over the years have gone through these programs. But in Brown's typical fashion of trying to be a little different about looking at problems, we look at the fringe of how those classical areas affect us. So we could be looking at the science of bubbles that arise when champagne is poured into a bottle, for example, or into a glass. Or it could be the fluid dynamics of the ocean actually hitting the coast and the type of erosion that it has based on that, and to try to model that and to innovate in terms of our understanding of that. A lot of this is compute oriented. So we spend a lot of time with resources to allow us to compute very large models and to build some real specificity to our research areas as well. So this whole area of fluids and thermal sciences is a hot area for us, but generally we're trying to apply it in unique ways using deep research or deep mathematics to explain how our research may be different. Next slide. A really good example of that is Anoop. Now, he was a master's just a couple years ago, and we call him an advisor for the program. So if you ever want to talk to somebody who's been through our programs more recently, Anoop is a really good example. And he does work in the area of fluids and thermal sciences. But what he realized is that the flow pattern related to some of his fluids research was very similar to what happens when a drone flies and propels itself. So over the years, I say Anoop has had a day job of actually understanding the classical fluids and thermal sciences, but the night job that he has been studying drones and how they propel themselves, which is a brand new area for the world. And so he's able to apply that type of classic thinking to new problems that we have today. So drones are everywhere. If you watch the Olympics, you can see them in every event that we have. And they're very important use cases that we solve with drones. And so he's spending his time applying that classic theory to something that's very a new technology for us. And now he's getting his PhD and making great progress with his research. Next slide. In biomedical is an area, it's probably our highest concentration that we have as undergraduates. We have a lot of interest at the graduate school as well. This is a highly collaborative area between the medical school and the School of Public Health and biology and chemistry and engineering as well. So all these guys are mixing together. There's such innovation happening in this area. There's such miniaturization going on. So we're putting integrated circuits in people's brains, for example. All this takes a broad view of the overall research and technology. And so you can see a lot of investment, a lot of students pursuing biomedical type degrees at all levels with undergraduate, master's, and PhD. Next, please. And as I mentioned, computing is important. We have a data science discipline or concentration called DESIS. Several faculty members both contribute to the innovation in that area, but also use the resources for their own types of research that could be, finite element analysis for a mechanical engineering problem or design, for example. Or it could be a study about the population of certain types of virus, for example, the growth of those. It could be a variety of different things. So you see a wide mix of disciplines working closely with our DESIS team to use their resources and their approaches to provide data science behind the research that's going on. Next, please. We have one program that's uniquely available for just masters. It just started by Kamani, I mentioned before, a dean of the organization. And we're trying to look at digital health in new areas using newer technology. And it's called the Breath Program. And it gives you an opportunity uniquely to do research as a master's student, as opposed to a full-fledged PhD doctoral program that's going to go on for 5 or 6 years. This is giving a taste for different grants in the area of digital health. And again, very collaborative in different areas, whether it's optics or mechanics or some of the miniaturization that we're doing with electronics, for example. All these things are factors in our area of digital health, and Kamani's program, Breath, is trying to get some funding to allow masters to really focus on what digital health is all about and how to innovate in those areas. Next slide. And electrical and computer engineering, which is really my cornerstone, has always had tremendous amounts of activities going on, whether it's wireless communications or photonics, for example, or high-speed communications, embedded systems, embedded bioelectrical devices. You can see the long list of acronyms and programs that we have underway, but this program has been around for 50 years, and we have a variety of different research and grant activities that you can get introduced to. Now, typically, you're going to get introduced to those research programs when you take classes with certain instructors, and you'll find out the classes are generally smallish for the master's programs, and you'll get a real firsthand view of what that field is all about and get a good working relationship with your professor, who typically would be a PI in one of these areas. Next, please. And if you want to really focus on something that's new, cutting edge opportunity in the working world, design is a great area. You look at the quality of products that we ship, whether it's the smartphones of the world, Apple really changed our thinking in terms of the elegance of design and building really quality product that looks and performs beautifully. And we partner with RISD in this case to build this program called MADE, which allows you to understand both the technology behind a innovation or a product area, as well as some of the design aspects of it as well. And how do you build this in the most elegant way? And how do you communicate that to your consumer that this is a great design? And so if you're really interested in design, which is a hot area in the industry for sure, this is a way to formally get trained in that area through this collaboration that we have with RISD as well. And what I've been working on also is trying to find opportunities for our master's students to work after they finish their time at Brown, especially in that professional track option. So we have a program called the Co-op program, which is open to allow you to get a deep dive opportunity with a company that would appreciate the skills that you're developing in the classroom. And so it could be anywhere between 3 to 6 months. So it's not just like a summer internship that you're spending 8 or 10 weeks with. It's a more serious commitment. You're getting paid for that opportunity that you have. You're working very closely with a high-end team that really knows how to use your skills. They get to know you, you get to know them. It's really an extended interview process. And we'll give you a really good feel for whether that's the vertical market that you want to go into work for as well. If you go to the next slide, we have an example. And so this is like I mentioned with Anoop was an ambassador. We have another ambassador, Will Wu, that was really focused to getting his master's in robotics. So he was taking computer engineering and computer science classes to understand all aspects of robotics. And then he wanted to go put that to use. And so he went to work for Amazon here in New England. And he worked specifically on the Proteus project, which was all about their factory automation and using robotics to do that. And Amazon liked it because they had a full worker available for 6 full months and very focused, very productive, obviously trained with the leading edge of techniques in the classrooms. And at the same time, Will got a really good taste for how that company operates and how that industry was. What he learned at the end of his co-op program is he actually didn't go back to work for them. He had an offer, but he actually decided to come back to Brown, get his PhD, and he's working on Brown robotics as well. So, he went through this co-op program. He took it very seriously. It was a great opportunity for both parties. But at the end of the day, it showed what his real passion was to actually back in academics. And so that's what he's pursuing as we speak. But this is a great path for many of us that want to get back into industry and really work for one of the major players in the market after I've learned a bunch of new technology and new capabilities in the classroom. Next slide. So you may be confused by all these different choices and options. Now, I told you in the opening slide that advisors like myself and Nora actually will work closely with you to design the proper program for you. We put all that, we codify that into a handbook. Each concentration, in my case, electrical and computer engineering, has built a handbook that shows different templates of classes that you will take during your 2 years at Brown. So, for example, if you're interested in signal processing or medical imaging, for example, then we enumerate these are the classes that you should be focused on. Now, we want you taking advanced graduate level classes. We don't want you having broad focus on undergraduate stuff. We want to challenge you with the latest and greatest thinking for sure. So there are some very well-known classes that we will steer you towards as well. And if you wanted to be more focused in getting the job after the master's program, the professional track, for example, yeah, then we'll show you how to design that program to have the right initial classroom work, but then the right classes that you take to allow you to get out in industry and kind of share with them some of the things you're learning. So we will know specific by track what would be the right type of classes or the template that you should pursue. And you will work with your advisor on a semester by semester basis for as long as you're at Brown to tune that plan and make that as effective as possible. And this is a document we can make available to you as you get closer to your decision with Brown. Next slide, please. And we love veterans being in the program. I have several in my undergraduate electronics class that we're teaching right now. So if you are that veteran that made a commitment after high school to defend the country, we thank you for that. But at the same time, you may decide you want to change gears and work in an IT space, for example, and Brown would be a wonderful opportunity for you to get that advanced training and possibly introduce you to some new opportunities to go work with as well. A lot of good funding here. It's a very strong community for veterans at Brown. So if you have an interest at all, please speak up and we can connect you to the right groups. And this is my last slide, but the thing I would say to all the prospective applicants, first, we encourage you to join because we're very bullish and we think it's a great timing to do so. But there's really not a bad choice in this set of things that you're evaluating. If you go the professional route, you can do research both at an academic level or with a company, so you have that choice. But if you get into a master's program and you decide that you really want to get your PhD or a doctoral concentration in a certain area, we have great working relationships with many of these schools that you will recognize by brand alone. So you really can't make a bad choice. This is an investment in yourself. And my goal as a program advisor is to make sure that the 8 classes that you take are giving you the absolute best experience possible, the best training that you need for whatever that outcome may be, whether it's academic or professional. Uh, so that's kind of my update. I'm more than happy to answer any questions. They typically come out as we go on throughout the session. Thank you for your time. Next.
Awesome. Thank you, Ted. So I've got some information to share more broadly about Brown, but of course, continue to use the Q&A to submit any questions that you have about the program. So I like Ted was saying earlier, Brown is located in Providence, Rhode Island. Providence is a small city in New England, but very easily accessible from major cities in the Northeast. So we're just about an hour away from Boston, a couple of hours away from New York. Really easy to get there by Amtrak or for Boston, the MBTA from Providence. The city itself is walking and biking friendly. You don't necessarily have to have a car, but you certainly can have one, which will allow you to travel a little bit further afield if you want to get into some outdoor activities in Rhode Island, but also sort of in more of the New England area. There are things to do in Providence. There's a zoo, there's museums. We have a great relationship with the Rhode Island School of Design. You get free entrance as a Brown student, so you can go into any of those museums, as well as, of course, Brown has a lot of really wonderful activities that you can participate in. Rhode Island is the ocean state, so lots of beaches. If you like water sports, you're here over the summer. The beaches are really easily accessible from Providence. I will also say that in terms of like things to do in the area, there's like state parks if you want to get out a little bit more. But then also, if you have friends in other cities, I think one thing that's really common is, on the weekends, students will go to Boston, go to New York, go to Washington, D.C., and explore a little bit more, visit friends. But then also, it's a great professional opportunity. So there's a lot of really excellent opportunities in terms of networking professionally that you can do in those cities, but then also in Providence. Providence has a really vibrant culture. Here's a map of just Providence. The little towns, or I should say neighborhoods with the hearts over them, are where our students tend to congregate. So the vast majority of our classes are taught on College Hill. College Hill is where the School of Engineering building is. Our graduate student housing primarily is in downtown in the Jewelry District. It's just a 15-minute walk from the Jewelry District up to College Hill. So Brown has a wider footprint beyond just College Hill, but it's really easy to get to and from. So we have the Brown University Shuttle, which you have free ridership on as a Brown student, which will take you to really anywhere Brown is a footprint. Brown also has some apartments in the College Hill area for graduate students to rent. Housing is all on a first come, first served basis, though. So keep that in mind as you're applying. The earlier that you apply, the earlier you're admitted, and the earlier that you can get on housing wait lists. But there are also a lot of really excellent restaurants. We definitely are batting out of our league in terms of great food in Providence and in Rhode Island. So a lot of the areas that you're seeing with the hearts over them tend to be really for the culinary areas. Like Federal Hill is a good example of a ton of really great Italian restaurants, and so on. You also will get free ridership on the Rhode Island Public Transit Authority buses. So like I was saying earlier, getting a little bit further afield is really easy. I want to highlight here the Center for Master Student Excellence. We have a number of centers and offices at Brown beyond sort of what you're just seeing on the screen. Really, the home for our master's students at Brown is the Center for Master Student Excellence within the Division of Masters and Professional Programs. And one of the things that really makes Brown unique in the landscape of master's programs in the United States is we have dedicated resources for our master's students. So we have career support, professional development, academic advising, student affairs, really all geared towards master's students. Because if you think about it, our undergraduate students are with us for 4 years, our PhD students are with us for 5 years, master's students are only with us for 2. So you really need to hit the ground running in terms of getting ready, career support, professional development, so that you can meet your goals when you graduate. One of the things that we do in the Center for Master's Student Excellence is we coordinate with all of the offices and centers that you're seeing on the screen, as well as the academic areas. So we're there to help with connecting you with vital resources through student affairs. If you need accommodations in the classroom, you have an emergency that needs to be addressed. Also, career support and professional development will partner with the School of Engineering to offer specific career advising. So really, it's the first stop for you. If there's ever anything that you need, you can always stop within the Center for Master Student Excellence. We have open office hours, advising appointments, things like that for you to connect. Talking a little bit more about career support and professional development, I was saying earlier, we have these layers of support at Brown, really starting with your home department in the School of Engineering, excellent student affairs staff, faculty who have experienced the things that you're experiencing, who can assist you in terms of networking, helping you figure out what you want to do professionally when you graduate. But then additionally, we have the Division of Masters in Professional Programs. We have that career advising that will help you with your cover letter writing, resume, optimizing your LinkedIn profile, making connections with folks who want to recruit at Brown. We have STEM specific career advising as well. I'd really encourage you to check out our master's career website. I think that's a great way to see sort of what opportunities might be available to you through the Division of Masters and Professional Programs while you're at Brown. Beyond the Division of Masters and Professional Programs, we have career fairs that are run through the Center for Career Exploration. The Center for Career Exploration really sort of more broadly offers career opportunities. We use Handshake, which is offered through them. There's also the career fair as well as recruiting events that they'll offer. The job, like I was saying, job and internship opportunities are posted on Handshake. There's a ton of activity happening both internally as well as with recruiters on Handshake. And then one of the great perks of attending Brown is you have access to our alumni base. So also, we have Brown Connect, which puts our current students in contact with alumni. And then also, of course, you then become an alumni of Brown and you continue to have access to a lot of these resources. So let's talk through the application. So high level, these are the requirements for the application. So we're going to have you submit your transcripts. Unofficial transcripts are fine for the purposes of your application. However, if you do end up being admitted and matriculating at Brown, we will eventually require you before you actually start classes to follow up with an official transcript. If you attended an institution outside of the United States for your undergraduate degree, we will not require a credential evaluation as a part of your application. However, much like with the official transcripts, we will eventually require you to follow up with a credential evaluation that includes a degree conferral information, your CV, your resume, which will outline your research, work experience, things that you've done outside of the classroom and inside of the classroom, your personal statement, which should outline your goals, experiences, really related to the specific discipline that you're applying to. You should talk about why you're interested in Brown, why you're interested in that particular discipline. Some of our School of Engineering programs are also going to require a video essay, which is really just a response to a prompt. So as you move through the application, you'll eventually get to the point where you have access to the video essay. It's a randomized prompt, so we don't offer them in advance, so there's nothing to really prepare for. We really just want to get a sense of your sort of in real time answers to these questions. We require 3 letters of recommendation as a part of your application for non-internal applicants. So anybody applying from outside of Brown, 3 letters of recommendation. We require all 3 in order for you to be considered. So make sure that you're asking for all 3 letters of recommendation and that you're following up with your recommenders. You can submit letters of recommendation from folks who've taught you in the classroom, folks who know you professionally. Really, they should be people who can speak to you specifically and speak to you really highly. It should be more than just this person got in a 10% of grades for the course that I taught. It should be, how is this person as a member of an academic community? How will they succeed in this particular academic program? And then here's the experiences that I had that back up those claims. We require English language proficiency exam scores for anybody whose native language is not English. The only way you can satisfy that requirement is through either the TOEFL or the IELTS. So you'll have to submit English language proficiency exam scores. If your native language is not English, we will waive that requirement though if you have a degree from an institution where the sole language of instruction is English. And then, of course, for all the School of Engineering master's programs, we do not require the GRE anymore. Here's a matrix of all of the deadlines. So right now we are looking ahead to fall of 2026. The priority deadline has passed for all of our engineering programs. So the next deadline we're looking at is in April. So keep that in mind. The final deadline is April 1st. So make sure that you're submitting your materials by then. We also have a spring intake in 2027. So if you're early for that, that's great too. We have that information here as well. So definitely follow us on social media. I always say one of the best ways to get a sense of an institution is to see us on social media. Look at us on events at Brown so you can get a sense of the speakers that we're bringing in, the events that we're having that are available to you so you can see sort of what your life would be like. But definitely social media is a great way to do that as well. And then if you have any questions, you can always be in touch with us, masters_admissions at brown.edu if you're having any issues with the application. And then if you have any program specific questions, you can reach out to the program directly at the emails that you're seeing on the screen. So thank you for coming. I think now, Ted, we can sort of start with that Q&A if you'd like. There's one currently in the Q&A if you want to take a look at that.
Okay, let me check it out.
Sort of lengthy. So the first part of the question looks like, would you accept recommendations from professors in a home country for international students? And I think, yes, of course, we would accept letters of recommendation.
I think we'd kind of expect that.
Yeah.
But as you get further away from the campus, if you work with someone closely, those would be very good recommenders as well on the work front. Environmental engineering is a program that we have. I don't know how it exists side by side with the new energy focus that we have, but it is absolutely an area for us. And Rhode Island is an interesting environment in general from a physical science point of view as well. So I have to go back and understand the depth of that program and how many participants we have, but we're absolutely welcome you to apply for that program as well.
Thank you for that. Question that was submitted in advance of the session about funding opportunities. So I want to talk a little bit about sort of the landscape of funding for our master's programs. The majority of our master's students don't receive any funding for the program. Funding is very program by program for master's programs in general. There's not sort of like a specific scheme that's applicable across every master's program or every institution. I will say that there are job opportunities for master's students at Brown. We hire TAs. Folks get paid to do research. Generally, those are done on an hourly basis, so it helps defray sort of that cost of living. But Ted, I don't know if you want to talk a little bit more about like the co-op and other opportunities to earn money, and scholarships that are department specific.
I mean, the co-op is a great place to start if you're really focused on of how you're going to thrive in your career and get paid for it. Like the example that I showed with Will Wu working for Amazon, I think he amassed something close to like 40 or 50K US dollars during that 4 or 5 month period that he was working with Amazon. So it can be very significant to be receiving that kind of salary while you're also going to school, so you can subsidize in a lot of ways your degree. I always look at this a little differently. Like you made an investment in yourself, you get your degree, and then you're going to be at a different level of job opportunity when you graduate. I know this from my own kids, for example. They've made the investment, they got their master's degrees, and they get some really top-notch opportunities, whether it's with SpaceX or somebody like this, that is really going to be there in the long run. And you just see that over time, that money should get paid back very quickly. I feel strongly about that part. So there are different mechanisms to get funding. There are occasionally departmental and concentration scholarships that we offer based on your overall merit throughout your undergraduate programs and some other factors as well. So there are always opportunities. We try to do that, but I think this is more about making an investment in yourself with the opportunity to get a better job opportunity in the long run.
Thank you, Ted. I'm just going through the questions to make sure we
Yep.
answered all of them. Are there any particular qualities that you see in successful applicants to the programs? I think it's important to note the audience for your application are School of Engineering faculty members like yourself.
So I'm right in the middle of looking at several hundred applicants with a couple other faculty members. And the thing that I always go back to is that people are always very technical and can solve any technical challenge in any field. That's usually important, but what's also important is how well they communicate and how clear they are in their application as to what their goals may be. So those softer elements do matter quite a bit. And certainly it will matter if you get into a research team or you're being collaborative in your classwork with different departments, how you communicate or how you size up a problem and work through it and how you agree to collaborate with other members. If you could show any examples of that, that's very effective on the application. That's what I look for in the letters of recommendation, for example.
Another question that was asked was about like student accessibility services for students with disabilities. And we have a student accessibility services office. So that would be the first place to start. So the office is called SEAS, SEAS, I believe. So that would be the first place to start. But of course, you can start with the Center for Master Student Excellence to get connected with those resources for that support. Um,
There's a question here about what are the GPA requirements. I wouldn't mind addressing that. Do you
yeah, that
have
would be great.
Yeah, so I mean, it isn't a clear-cut decision. And one of the things I've noticed after looking at hundreds of applicants is people come from different schools and different curriculums, and the way they keep score is different. In India, it's different than China than it is in the US, which is different in European schools, for example. So, the grade scales that you have. What matters to us is looking at your transcript and picking the classes that are most representative to the concentration that you're going into. So that's not to say that you shouldn't have a diverse undergraduate degree, but you have like physical education or a member of a musical group. Those are interesting activities, but they don't really contribute to like electrical and computer engineering necessarily. So we will generally filter the transcript and look at the courses that we think are most relevant for where you're trying to get an advanced degree. And then we'll look at the GPA from that. And generally, we would expect that students should get mostly A's and high B's in those classes. It's not always the case. There's an opportunity to explain why you may not have had a great outcome for one of the undergraduate classes. It happens all the time. So please do that. But generally, we're looking for areas that complement the degree you're going after and that you're passionate about and you find it easy to understand and do well in those particular academic areas.
Great. So I think that's it for questions. Ted, thank you so much for joining, and thank you so much for answering questions and keeping us on track in the background. But if folks have any questions, they're obviously y'all are more than welcome to reach out. Anne's provided some email addresses in the chat that you're welcome to use. But other than that, have a great rest of your day.
Yeah, I have my email in the chat if anybody has any specific questions to the topics that I covered as well. Feel free to reach
Fantastic.
out.
All right, everyone. Bye.
Have a great day. Thank you.